digital experiment that models an adiabatic flash drum. And the idea is that we're going to feed a liquid at elevated temperatures. So we're going to fill this tank and feed a liquid through a heater, use steam heating. We set the temperature, and then we lower the pressure. And again, the pressure can be set so that some of the liquid vaporizes, leaves out the top. The rest leaves the bottom. We are measuring some flow rates by flow meters, as indicated here. We're measuring temperatures and pressure. And then we can take a sample of the liquid and inject it to get the composition. And then the idea of the experiment, we use mass balances to determine the other values and check that everything is consistent. So we also use Antoine's equation to get saturation pressures and apply Raoult's law for vapor-liquid equilibrium. So let's look at this simulation and see how it behaves. So if we select here, we can see we have directions, information about the simulation, and then a detailed worksheet that explains what experiments to do. You can see we can pick which mixture we're going to use. Let's pick mixture A, and we're given Antoine's constants, molecular weights. We can pick the feed composition. And so now we can fill the tank. We can select a pressure for the tank. We can select the temperature of the feed. And the idea is we have steam that's going to heat that feed up to this temperature. Then we turn on the feed pump. We allow the system to reach steady state, so it takes a little bit of time to do so. What we'll see, 5.23 kilograms per minute are being fed, and then 4.44 kilograms are leaving as a liquid, so the rest is leaving as a vapor. Here's the pressure, here's the temperature for the feed. This is now the temperature inside the drum. And so the temperature drops because we vaporized some fraction of the liquid feed. And then we can take a sample for the liquid and inject that. So this is a mimic of a GC where we inject a liquid with a syringe, and it gives us the mole fraction of the liquid for component 1, the more volatile component. And so we can go back to the experiment. We can now apply mass balances, Raoult's law to this system to obtain the other values and check for consistency. So it's very similar to type experiment we might do in the lab, but we can do it much more quickly in this simulation.